VCF contains a declarative Kubernetes API which enables a set of services for consumption of infrastructure. The API facilitates container deployment in multiple ways across VCF. The services include Kubernetes clusters, individual VMs with instance provisioning through Cloud Init, persistent volumes, load balancers, and vSphere pods, which are containers deployed directly on the hypervisor. Let's start by deploying a Kubernetes cluster. The Kubernetes releases package the Kubernetes version and now iterate independently from vCenter. This facilitates faster release delivery and accelerates releases of Kubernetes to VCF within 2 months of upstream release. Users like choice in their cluster overlay networking. Multiple options are available for implementation of the CNI. Users control cluster availability by choosing the number of control plane replicas. Administrators can limit VM sizing and hardware configuration by defining the VM classes that are consumable by users. Worker nodes are configured using node pools to define sets of nodes with identical configuration. One node pool might contain medium-sized VMs and use Ubuntu as the base OS. Persistent volumes can be created and are automatically backed with VCF storage volumes. This is useful for applications like NVIDIA that need more space when running their GPU operator. We might create a second node pool that will define worker nodes with a different OS. Users could even select Windows 2022 to support Windows containers. Notice the automatic generation of YAML that implements the upstream Kubernetes Cluster API project's recommended way for provisioning Kubernetes clusters. We've been an active contributor since its inception. The Kubernetes cluster service takes advantage of the VM service to provision the cluster's VMs. The Kubernetes cluster is provisioned in the context of a vSphere namespace that provides policy constraints in terms of resource consumption and user access. A vSphere namespace is the area where all consumer resources are placed. As part of the cluster creation, the VCF network service has automatically created a load balancer service to enable availability and access to the cluster. And the VCF storage service created a Kubernetes persistent volume and backed it with a VCF virtual disk. Supervisor services allow the administrator to enable specific apps for their developers. They run as vSphere pod containers directly on the hypervisor. Here we have deployed the Harbor container registry. A confidential vSphere pod can also be deployed onto secure hardware and provides memory encryption and CPU registry protection. And finally, using the same API surface, we can now deploy a developer workstation virtual machine. It will have developer tools like kubectl, but will also run Docker locally to enable development work. In addition to the VM class and load balancer configuration, we paste in the cloud config that will create a user and install Docker. This config is stored in the Kubernetes secret, attached to the VM and implemented using Cloud Init. VCF IaaS control plane, enabling a complete developer environment through a declarative cloud consumption experience.